Okay, so before we start getting into operations on sets and just general things you can do with sets, now that we understand a little bit of the notation and a little bit of what a subset is and stuff like that, I'm just going to point out a couple of sets that are very important for your classes that you're going to need to understand before getting into it. So probably the most important set that you can ever know about is this, which is phi. It's the empty set. It's a set that contains nothing. The empty set has nothing in it, and also the empty set is a subset of every single set. If I have the set 1, well, the set that contains nothing is a subset of that. Now you can, I would encourage you to look at the definition of the subset and try to figure this one out yourself. But if you're stuck on it, subset means that every single element inside of a set is also inside of the other set, right? And there are no elements inside of this set, which means that every single element that is in this set is inside of this one, because there's nothing in this. It's kind of confusing to wrap your head around, but if you go through the definitions, it should make sense. This next set and this set is especially important for you CS 241 kids in discrete mathematics. This is the set of natural numbers. Natural numbers, it's just 1, 2, 3, 4, 5, 6. It's all the positive whole numbers. Sometimes there's a debate of whether or not you include 0 in here, right? That's a question. That's up to personal preference. I'm going to not include it. I'm going to say it starts at 1, because sometimes that makes things a little bit easier. But it's important to understand what your professor is talking about, if they're including 0, if they're not including 0. Okay, this next set is also very important for CS 241. And this is the set of integers. These are just all the whole numbers. It includes negatives. It 100% includes 0. That's just one of the defining features. It has 0 in it. It has all the negative numbers. It has all the positive numbers. Right, the next set is the rational numbers. So the rational numbers, again, it includes all the negative whole numbers. It includes all the positive whole numbers. But it also now includes fractions. So anything that can be written in the form p over q, where both p is a natural number, and q is also a natural number. And it can also be negative, so we can include plus or minus p. So that's the set of rational numbers. It's all the fractions. Finally, for our sets of numbers, and this one's going to be the biggest set in Math 480. This is the set of real numbers. So it includes every number, not just fractions, not just whole numbers. It includes things like pi, and includes things like e. And you might be wondering, what makes this set different than this set? Like, why are there numbers in here that are not in here? Like, what makes pi not rational? What makes, like, the square root of 2 not rational? How are there holes in this? And are there any numbers that are missing from here? Is there a bigger set that we need to consider? Those are some important proofs for Math 480 that you're going to get into. And then this final set right here, it is the opposite set of the empty set. So the empty set is a set that contains nothing. Well, this set right here is called the universal set, and it contains everything. Everything. If I was to take any set, literally any set, it is always a subset of the universal set. Now, you might be wondering why we even need that. Like, why do we need a universal set? Well, it will come into play in the idea of complements in the next few lessons. So it is important. We do need it. And before I go, it is cool to notice that all of these sets, in the way I listed them, are all subsets of the next one. Subset of R, subset of U. So the empty set is inside of the natural numbers. The natural numbers are included inside of the integers. The integers are included inside of the rationals, which are included inside of the reals, which is included in the universal set because the universal set has everything. And I mean, I guess you can, in theory, also put here the set C, which is complex numbers. But complex numbers, They're not that important for CS 241 and 480, so we can just ignore them for the time being. And with that, that is the end of the introduction to set theory. We're going to be moving on into things like operations and stuff like that in the next lesson, so look out for that.